Space, the final frontier, a vast, unexplored expanse that has captivated humanity for centuries. Our journey into the cosmos began with the launch of Sputnik, the first artificial satellite, followed by the triumphant moment when mankind set foot on the moon. Then came the Mars rover expeditions, opening new frontiers and fueling our curiosity. These moments in history have not only expanded our knowledge of the cosmos, but also sparked a burning desire to go beyond, to colonize space. However, the road to becoming an interplanetary species is fraught with challenges. Let's not forget that space, in its vastness and mystery, is not inherently hospitable to us. We are terrestrial beings, after all. Our bodies and minds have evolved over millions of years to thrive under the conditions of our home planet, Earth. When we venture beyond our atmosphere, we encounter a whole new world of trials. Consider, for instance, the invisible yet insidious danger of radiation. In the vacuum of space, cosmic rays emanating from distant supernovae can penetrate spacecraft and astronaut bodies, damaging cells and increasing the risk of cancer. Current shielding technologies can only do so much to protect us from this omnipresent threat. Then there's microgravity. In the weightlessness of space, our muscles and bones, no longer battling against Earth's gravity, begin to weaken. Extended periods in space can lead to significant muscle atrophy and bone density loss, making recovery back on Earth a long and painstaking process. And let's not forget about the psychological toll of isolation. Imagine being confined in a small spacecraft for months on end, with the same faces, the same routines, and the vast, silent expanse of space outside your window. The psychological impact of this isolation and confinement is a serious concern that needs to be addressed. As we reach for the stars, we must first overcome these hurdles that stand in our path. Only then can we truly become a spacefaring civilization, ready to explore and inhabit the cosmos. Despite these challenges, one celestial body has captured our collective imagination: Mars. The red planet, as it's often called, has long been a beacon of curiosity and wonder. Its similarities to Earth are striking. Take the length of a Martian day, or Sol, for instance. It's only slightly longer than an Earth day, clocking in at about 24 hours and 39 minutes. But it's not just about time. Mars also holds the potential for water. While the Martian surface is harsh and dry, there's evidence to suggest that water, the lifeblood of our home planet, exists in frozen form within its poles and beneath its surface. This potential for water, coupled with its Earth-like day, makes Mars a tantalizing prospect for human habitation. It's a place where we might, one day, establish a new home for humanity. In many ways, Mars is the most Earth-like planet we've found, making it a prime candidate for colonization. But how do we reach Mars? And more importantly, how do we survive there? As we ponder these questions, we must consider the advancements in spacecraft and propulsion systems. The future of space travel hinges on technologies like ion drives and nuclear propulsion, systems that could potentially cut travel time to Mars by half or more. But reaching Mars is only half the battle. To make space colonization viable, we must focus on sustainability. Harnessing local resources is crucial to support human life on the red planet. Imagine using Martian soil to build habitats or extracting water from its frozen reserves. Moreover, advanced life support systems are in development, designed to recycle air and water and provide food for astronauts during lengthy missions. These systems are the linchpin for survival in the harsh environment of space. Space colonization is not just about getting there, it's about living there. And with these innovations, our dreams of colonizing the cosmos are becoming increasingly attainable. As we dream of colonizing Mars and beyond, let's dive into some mind-boggling facts about space travel and colonization. First, let's talk time dilation. Thanks to Einstein's theory of relativity, an astronaut traveling near the speed of light would experience time slower than those on Earth. A year-long voyage could equate to decades, even centuries, passing by on our planet. Next, let's consider terraforming, the hypothetical process of altering a planet's environment to make it Earth-like. Mars, with its day length and seasons similar to Earth's, is a prime candidate. However, this process would take thousands, if not millions, of years to complete. Finally, let's not forget the potential for discovering extraterrestrial life. Scientists have found extremophiles, organisms that thrive in extreme conditions, right here on Earth. Could similar life forms exist on Mars or on the icy moons of Jupiter and Saturn? As we continue to push the boundaries of our understanding, who knows what fascinating discoveries await us in the cosmos?